I guess we're going to go ahead and talk about our inscribed angles now. Our inscribed, now I've talked about in my class before, inscribed is going to mean drawn inside. So our angle is going to be inside, but most specifically, it's going to be an angle whose vertex is on the circumference and the sides contain chords. So we're going to draw one. Over here, if we draw our circle, anywhere on that circumference, on that circle, we're going to draw a point. We're going to create two chords from this. We'll just go over here, there's a chord. Then we can take it anywhere else over here, there's another chord. Your inscribed angle is this angle right here, okay? So on this picture, on example 1, we do see a triangle, but more specifically what I need you guys to see is we do have 3 inscribed angles. On this problem, they do want us to identify all inscribed angles and their corresponding intercepted arcs, so the arcs that they create, okay? So the first one we'll take a look at here is we're going to have, let's start with angle DOG, okay? So we have angle DOG is an inscribed angle. Its intercepted arc that it creates is arc DG. Then we could take, let's get a little colorful and messy here. We can go from O to G to D. So we have angle OGD. The arc, intercepted arc that it creates over here is arc OD. Lastly, we have the last angle we haven't mentioned yet is going to be angle ODG. That's going to be the other inscribed arc, or sorry, angle, and its intercepted arc that it creates over here is OG. So arc OG. So just letting you know, see what that looks like. Now, we're going to start off kind of simple and talk about how do we find the arcs, the intercepted arcs, how do we find the inscribed angles. So first things first, we're going to take a look at if an angle is inscribed in a circle, like this one is, then the measure of the angle is half the measure of the arc, okay? So the angle is going to be smaller than the arc. Your central angle, they were the same. This is different. We're no longer in the center. So now we're going to take half of the arc to get the angle, and then vice versa for to find our arc. Here, we're told that the measurement of the arc BC right here is 100 degrees. But we want to find the value of x. We want to find this intercepted arc down here. The problem is we don't have arc your inscribed angle. We don't have arc AB, so we have to find it. Well, if you take a look, we're going to look at the measurement of arc ABC. Follow that around. ABC is equal to 180 degrees because it's a semicircle. How do I know? Because segment AC is the diameter, cutting the circle in half, creating 2 semicircles. So all we have to do here is say, therefore, arc AB, what we're looking for, is equal to that 180 minus that 100 we already have, giving us 80 degrees. So this appears 80 degrees. When we look at our inscribed angle, okay, angle ABC, the measure of angle ABC will be equal to half of arc AB. So that will be half of 80, leaving us with the measure of angle ABC being 40 degrees. Okay? All right, so on to our next page, we have inscribed angles of a circle theorem. What this is going to state is that if we have 2 inscribed angles, okay, so we don't have just one like we did earlier, we have 2 of them, they have intercepted congruent arcs, or the same arc, okay? then the angles will be congruent. So if the arcs are congruent, the angles, the inscribed angles will be congruent. And vice versa. If the inscribed angles are congruent, then the intercepted arcs will be congruent as well. So when we take a look at the first problem here, we're told that the measurement of the measurement of arc ST, so right here, is going to be 68 degrees. It's going to play an important role. We want to find measurement at angle 1 and measurement at angle 2. Well, what we need to see here is that measurement at angle 1 is right here. And look where its intercepted arc is. Its intercepted arc is ST. Then if we take a look at angle 2, look at where its intercepted arc is. It's also ST. So this is where that same arc comes in. Both angle 1 and angle 2 share the same arc. So since they share the same intercepted arc, that's going to tell us that the measurement of angle 1 is going to be equal to the measurement of angle 2. All right? And so we are looking at inscribed angles. Angle 1 and angle 2 are inscribed. So we do need to follow that rule. And we'll just stick with measurement at angle 1 is going to be half of arc ST. So the measurement of angle 1 will be equal to half of 68. And the measurement at angle 1 being equal to the measurement at angle 2, they both will end up being 34 degrees. So notice what's going on there. They share that same exact arc. Now we're going to talk about the inscribed right angle theorem. So your inscribed right angle theorem, the big thing here is that right. I thought that was the highlighter. All apologies. We'll get that erased. Go down to the highlighter. We are looking at the right angle theorem. So we're going to have a 90-degree angle somewhere in here, okay? If an inscribed angle of a circle intercepts a semicircle, I need you guys to see that semicircle there. Okay, so if you have an inscribed angle on the circumference and it opens up directly to a semicircle, or it opens up to that diameter, then that's when we're going to have that inscribed angle is going to be a right angle. So let's take a look at the picture we have here. Over here, I'm seeing that, let me get my highlighter, switch colors on you guys. Over here, we have angle PTS. A little bit too light there. Angle PTS. I want you guys to see how it opens up to a semicircle. It's going to come across that diameter right there. So when it opens up and creates that diameter in that semicircle, that's what this theorem is talking about, that we're going to have that inscribed angle is going to be 90 degrees. The reason this happens is because your semicircle is 180 degrees. So if our inscribed angle down here is half of that, it creates 90 degrees. Okay, that's why that works out that way. So we're given information that I'm going to go ahead and clean some of this up for you guys. There we go. We have that measurement of angle 1 is going to be 55 degrees. And we have the measurement of angle 4 is 39 degrees. There is something that we're going to need to change on here. It says that arc PQ is congruent to arc PS. It's actually supposed to say RS, okay, because it wouldn't make sense any other way. So what that means here is that PQ right here is going to be congruent to RS over here. So we take a look at this. We're looking at finding measurement at angle 3 and the measurement at angle 4. The measurement at angle 3 is going to, get another color. The measurement at angle 3 is right here. It opens up to arc PQ. All right, that's its inscribed arc, or sorry, its intercepted arc. When we take a look at the measurement at angle 4, it's going to open up to arc RS. That's its intercepted arc. Well, as it said before, we've got up here, when we have the same arc or congruent arcs, so now we're looking at the congruent arcs part of it, they both open up to congruent arcs, so the measurement of angle 3 is equal to the measurement of angle 4, which was that 39 degrees. Okay, and I'm going to go ahead and, again, kind of clean this up to help us out with the next part. Now, when we find the measurement of angle 2, what we need to focus on here is going to be this triangle, okay? Triangle PST. We have a right triangle, and what we've learned before is with a right triangle, our two acute angles add to equal 90 degrees, because when you add your right angle in, you're going to end up with that 180. So, for the measurement of angle 2, all we need to do is at 90 degrees minus the 55 from angle 1 over here, and we're going to find out that the measurement of angle 2 is going to come down to 35 degrees. Last page. Next theorem. A lot of theorems on this one, ladies and gentlemen. This theorem is your quadrilateral, your inscribed quadrilateral theorem. If we have a quadrilateral, which we just got done with, we're just looking at a basic quadrilateral, not a specific, a kite, a rectangle. We're just looking at quadrilateral, 4 sides. All 4 angles add up to 360 degrees. What's going to happen is your opposite angles, if it's inscribed, drawn inside that circle, its opposite angles are supplementary. Okay, remember that supplementary is going to be 180 degrees. So we take a look at the first example here with our quadrilateral. We're told it's inscribed in circle C. The measurement of angle T is 95 degrees, and the measurement of angle S is 100 degrees. We want to find the measurement of angle Q and R. So starting off with the measurement of angle Q, we know that we have to add that to the opposite angle of the measurement of angle S to equal 180 degrees. So we have our unknown plus, well, we know what angle S is, 100 is equal to 180. Subtract that 100 algebraically. We find out that the measurement of angle Q is going to be 80 degrees. Now switching over to find angle R, measurement of angle R, same thing. You're going to add it to its opposite angle, the measurement of angle T down here, to equal 180 degrees. So our unknown measurement of angle R plus that 95 is going to equal 180. So let's algebraically subtract this to figure out what we're looking at. Your measurement of angle R, when we do that subtraction, is going to equal 85 degrees. Now, because quadrilaterals, all 4 angles add up to 360, if you add all 4 of those up, you will get 360 degrees. Okay, so number 6. There are a couple things that we need to start seeing here, okay? We want to find the measure of the inscribed angle. So we're looking for the measurement of angle XZY. Well, in order to find that, we need to take half of arc XY. Well, we don't have any of that. Oh, wait, yes, we do. Because back in the last lesson, we have our central angle here. So we have that angle XOY, what I just traced in red, is a central angle. Therefore, the measurement of angle XOY is equal to its arc, its intercepted arc, arc XY. So that means with that 90-degree angle, this central angle is 90 degrees, so is arc XY. So now that we know that that the inscribed angle XZY, we just call it angle Z, is going to be half its intercepted arc, arc XY. So we'll say the measurement of angle, we'll just kind of shorten it, Z, is equal to 1/2 of arc XY. So it'll be half of 90. So our inscribed angle, measurement of angle Z, will equal 45 degrees. Some of these pictures look complicated, but it's just a simple concept. The next one, we now have a hexagon inscribed. What we need to see here is when we talked about the last unit, we talked about regular polygons. A regular polygon just means that all sides and angles are congruent. Sides, congruent, okay? So what we need to remember there, get my eraser and clean that. Make it a little bit prettier for you guys. All sides are congruent. And we talked about here, if our sides are all going to be congruent, are the arcs, these chords. If all the chords are congruent, then their intercepted arcs are congruent. So all 6 of these arcs are going to be congruent as well. So what I'm going to do is I'm going to go ahead and erase all of those congruent markings and just mark my arcs congruent. So here, all of these are congruent. The reason why we're focusing on the arcs is because we talked about all the way around the circle is 360. Well, if all 6 are equal, we need to take that 360 and we need to divide it by 6, the number of arcs we have, to get each individual arc. And that's what this first one, A, is asking for CD, one of these 6 arcs. So 360 divided by 6 is going to give you 60 degrees. Okay? Next, let me get my change of color. We're going to be looking for the measurement of angle CFE. So CFE goes from C down to F over to E. So we're looking at an inscribed angle. We know this inscribed angle is going to be half of the intercepted arc. And we need to remember that we already talked about all of these little arcs here. All 6 of them are 60 degrees. So that means the intercepted arc, CE, is actually going to be 120 degrees. So we need to remember that our arc CE, is 120 degrees. So we need to take half of that. And then we're going to wind up with 60 degrees down here for our our inscribed angle. A lot of I words here. I'm going to clean this up because the next part's going to get, we're gonna have to kind of draw it. This is all going to be in the way. Okay, I know usually I don't do that whenever I'm on the document camera. But now we need to take a look and focus on, we're looking for the measurement of angle BCD. So we're going to go from B down to C over to D. Okay, so this is what we're looking for. Well, it's going to be half of our intercepted arc. And I'll use the same color with the highlighter on this one. It's going to be half of your intercepted arc. So I'm going to go in and I'm going to make sure that we remember that all of these, back to the pen. Come on, Miss Collins, you got this. Almost done. Each one of these is going to be 60 degrees. So when we take that 60 degrees and we have 1, 2, 3, 4 of them, we know that we're going to have the arc, we'll call it BFD. And I should be putting a measurement of it, is going to be that 60 times 4. That will give us 240 degrees. Our inscribed arc, BCD, our inscribed arc here, inscribed angle, measurement of angle BCD is going to be half of arc BFD. So we're going to have half of 240, and this will be 120 degrees.